dog over here, but I'd be afraid that they would have cyborg human puppies, which would be really creepy. Welcome to the Boca Raton Innovation Campus. My name is Angelo Bianco. I'm the managing partner of Crocker Partners. We own this facility. It's the largest office building in the state of Florida, one of the largest in the United States, actually at 1.7 million square feet. I'm very happy to be part of this event today in partnership with TEDx and the tireless work of Cindy and Eric has been fantastic in putting this event together. But it would not have been at all a success without my colleagues Danielle Bennett and Gianna Pacinelli, who have also been working for almost a year with TedXBoca. And so what we're trying to do here is we're trying to become part of the community and to open this facility up to the community and enhance it and become the tech and life sciences hub in the southeastern United States. And that's quite a task we've set for ourselves, but one that's doable, especially when you look back at our history. Because this facility was actually created 50 years ago, built by IBM as their Skunk Works headquarters. And they invented the personal computer right here, as well as the very first smartphone. In this room, well, maybe not this room, but in this building, the most famous business deal in the history of the United States happened when Bill Gates convinced IBM to license his software rather than buy it, turning him into the wealthiest human being at the time ever to live. So great things have happened here in the past, and we want to bring them back and bring to the future. We've started a program to revitalize this, and that's not just the physical aspects, but also energizing the minds and the imagination, the creativity in our community, and doing this here. And part of that is bringing people like these up here, who are much smarter and more creative than I am. But we all work together to create an environment that's going to foster that type of creativity. We are, from the real estate side, going to transform this facility into a Google-like campus, but for multiple tenants in the tech and life sciences industries. Most companies would love to have really cool food halls and presentation halls and state-of-the-art workout facilities, wellness and health centers, which we're planning on having here for all these events. A lot of high-end services, but you can't afford them. Even when you're a big tenant, like a 200,000 square foot tenant or 500,000 square foot tenant. But here, because of our mass, the size, we're able to do that. So we're going to be doing that, and one of the innovations that this crowd may be really interested in is that in addition to all of the amenities I mentioned a moment ago, we'll also be having the very first STEAM lab for a multi-tenant building in the state of Florida. And that stands for, I'm sure you know, science, technology, engineering, arts, and mathematics. We're going to have a full prototyping lab with 3D printing, laser cutters, CNC cutting, and a robotics lab. And the idea is to allow not just our tenants, but also their employees and visitors and guests to be creative here and build new great things. So with that, I'm going to turn this over to Eric. No, Cindy. Thank you very much.
So thank you all for coming. This is really, really exciting. We have an incredible powerhouse panel, and we want to say thank you to each of them. I know Eric's going to introduce them, and we're just thrilled to have so many people and the incredible response that we have for artificial intelligence. So I'm the co-organizer of TedXBocaRaton, and Eric is the organizer, and I have to also say thank you to our incredible team for TedXBocaRaton who are scattered around. We wouldn't be able to make this happen without them as well. The first organization, obviously, is BRiC, the Boca Raton Innovation Campus. They've been an amazing partner. They're actually our presenting partner for TedXBocaRaton. Gianna and Danielle, Angelo have been incredible partners and their team. This is the second TEDx Salon that we've had here, and the third one will be on September 12th, and we're going to be talking about communication. So, okay, a couple of people we just want to thank. 2 Degrees, I don't know if you have the opportunity to stop at the table out there, but 2 Degrees is a social deal app, and it's doing amazing things. They started at Tech Runway in the incubator space, and they're growing, and we're actually giving away, if you download their app tonight, they're giving away a free TEDx t-shirt, and we're also giving away tickets to TEDx. So if you haven't been able to stop by their table, please stop by. We wanted to thank the Container Game. I don't know if you were able to guess how many little robots were in that jar when you came in, but John here is the developer of another app called the Container Game. If you count how many, or guess how many robots are in that little jar, you can also win 2 tickets to TedXBocaRaton, and we want to thank our sponsors because without them we wouldn't be able to make these events possible. LivingFLA.com, Carrie, are you in the room to give us a wave? I don't know if Carrie's here, but he is an integral part of our events. He makes all of these things happen behind the scenes and promotes them, and we're very thankful and grateful to have him as a partner. And BNY Mellon, Melody, are you in the room? Melody, I wanted to introduce you as well. Melody is a great partner with BNY Mellon, and again, these events wouldn't happen without our partners. And we are trying to, as Angelo said, building an amazing community. Technology, entertainment, design is what TED stands for, and all of these businesses are coming together to create these incredible opportunities and bringing great panelists to bring us knowledge. I think I touched on the selection committee for the filings. So our main TEDx is October 26th at FAU, and we are in the process of finalizing the speakers. So we had about 150 speaker submissions for the main TEDx, and we're in the process in the next 2 weeks of announcing them, so that's a really exciting time. The next Salon is going to be, I mentioned, September 12th at BRiC on communication. Wanted to again thank our amazing panel here, and Eric will go into detail about each of them. And then partner opportunities, as I mentioned, we are building a community, and Angela mentioned it as well, so if you want to get involved with TEDx and these amazing organizations, please reach out to us. And I wanted to introduce my partner here in crime with TEDx. So give you a little bit of background about Eric. I'm a marketing and PR professional, and I always tell Eric that he is a dream client, even though he's not my client, he's my friend. He has an incredible background because stories, as you know, are what make the news and what make people want to do business with other people. So Eric has he's a South Florida boy, I guess, man, now, and 2 degrees from FAU. He got his MBA from MIT, so he's been able to bring some incredible speakers last year from MIT and this year as well to the TEDx stage from MIT. He started his career actually at IBM here at this very campus. He was here for 11 years, and then he went on to he created his own app and software, and it was acquired by Constant Contact, and he was with Constant Contact for about 8 years. So he has a really great story, and so we're thrilled to have him as the moderator today and also as the organizer for TedXBocaRaton. He's really making TedXBocaRaton a destination event for South Florida, and that's what our goal is. So thank you, Eric, and thank you.
So thank you to everyone for coming up. These salons are really kind of something new for us this year. It's exceeded our expectations, and it's a nice lead into the main event, which is in October. It's a lot of work to pull these events off. You know, it really takes a village. We couldn't do it without our partners, starting with BRiC. And then, of course, the team. It takes a big team. There's actually 2 people not listed here, but we're all volunteers, so I want to thank the team. This is not we don't make any money on this individually. It's a lot of work. Everyone has a dedicated role. It could be the salon, it could be the main event. When people aren't rowing, they actually get voted off the island. And you also notice that for every dude, there's like 4 women. So we get a lot of stuff done. So I want to thank Cindy. Cindy's a real gift for creating these really cool themes, and it really kind of gets to the heart of AI, being word intelligence. Garrett, where is Garrett? Oh, Garrett is our graphic artist, and he's the best I've ever seen, graphic artist designer, and he's responsible for this. So my mission as a speaker was to keep this simple, right? So when you walk out of here, you were more educated than when you walked in. Okay, so here's the rub. The more you learn about AI, the more questions you're going to have. This is kind of a universal truth. Okay, so we have 5 really gifted speakers, all practitioners in AI, and they're going to each get 5 minutes to take you through the machine learning, talk about the benefits of, and then as a group, I'll moderate, and you'll have 30 to 40 minutes to just barrage them with questions. So I'm going to start this off with just defining AI. This was a very simple definition that I liked the best from a professor at MIT that said that machines acting in ways that seem intelligent. It's very consumable, and I just want to unpack this for a second. So what's powering the machines, computers, devices, is really software. It's really about software manifesting intelligence. It's behaving, acting like. There is a very famous pioneer in the early days of AI. So the word intelligence is like a suitcase word. So if you think about a suitcase, you jam a bunch of junk in it. The word intelligence is actually one of these suitcase words, and what you fill the suitcase with is all these different definitions that make up the word intelligence. So if you were to ask Alexa to define the word intelligence, or you look in Wikipedia, you get something along the lines of the capacity for logic, learning, reasoning, discovering, problem solving, the ability to infer, perceive, adapt to your environment. Human intelligence is incredibly complex, and really the role of AI is about mimicking human behavior, and in essence creating a kind of intelligent agent. And the way I think about human or machine learning is really the brain of the intelligent agent. And it's kind of a black box. You give these machine learning algorithms a lot of data, and it does what it does, and it produces a result. It could be predictive, it could be pattern. But our goal here with the speakers is really to kind of demystify the black box of machine learning. Okay, so we are going to start. I'm going to introduce Manisha Bala from Office Depot. Now, this is going to be a little strange. They have a timer, and let's start the timer off.
Welcome everyone. Okay. Oh, thank you. So let me start by asking you guys a question. How many of you used Google Maps to come to this campus? Awesome. So you just experienced one of the most sophisticated AIs that's available today. So I'm going to talk more from a retail perspective. Retailers today are leveraging AI and machine learning to understand their consumers and their customers, and understanding who they are, where they're shopping, what they're buying, how to get to sell them their offerings and services in a more personable way. For example, Walmart is using facial recognition technology to analyze customer sentiment at checkout. So what that means is, at checkout lanes, they're watching your expression to see if you were satisfied or dissatisfied with the transaction. So next time you're shopping at Walmart, make sure you look up at the camera and smile. This is Cloverleaf's latest AI technology called Shelf Point, which enables them to understand customer buying behavior. So it not only captures customers' sentiment while they are picking up the product from the shelf, it also captures anonymous demographic details of who's buying, how much they're, what are the buying patterns, etc. This shelf can also be used for digital campaign management in store, and it also is used by some stores, including Walmart, for some other technologies like real-time price changes on the shelves for products. So, store associates don't have to print the price labels anymore. China actually has moved on the next frontier in terms of facial recognition. In China, there's huge. They have a huge database for facial recognition. They have their cameras supposedly everywhere when you go in China and big cities, and they're leveraging this facial recognition database to do a lot of cool stuff. There's less regulation in China, so they're able to store all this data. And I'm going to show you a small video on how they're leveraging AI. So in China, if you're trying to buy food or trying to buy anything, most likely you don't need your wallet or your smartphone to buy anything. All you need is your face.
This is me using my face to get into a convenience store in China where you can buy food through facial recognition technology. using your face to buy food that's already in reality. Here's one system that KFC and Chinese search engine giants Baidu implemented in China. KFC's system even remembers your face and food preferences so it can better recommend you new products. Much like KFC, this convenience store we visited in the city of Shenzhen has partnered with a tech giant, in this case, the payment app WeChat Pay, to create an experimental face-to-food experience. The store, Zhouheya, encourages people to play and pay with facial recognition technology. With just your face and a simple thumbs up, the system will deduct money from your linked WeChat account.
Pretty interesting. So next to the story about Target, and I'm sure a lot of you would have heard about this story, where Target actually predicted a teen's pregnancy before her father knew. Right? A lot of you guys know already, so for those of you who don't, your father walked into a Target store furious, demanding to see store manager, and he was furious that Target was sending circulars addressed to his teenage daughter about pregnancy items. The store manager apologized, and a few days later when Target followed up with the father apologized to Target, saying he wasn't aware, but his daughter was in fact pregnant. The way before Target closed its doors to media, the developer, the engineer who built this model, mentioned that they detect buying patterns of customers trying to buy certain products together, and they could not only predict if a customer was expecting a baby, but could also predict their due date within 10% of error rate. Now, obviously, customers got spooked, and there were a lot of controversy around this when Target did this. But what all Target was trying to do was reach out to their customers to sell the products before they become brand loyal in terms of baby category, right? That's what they're doing. So at Office Depot, we have built a real-time product recommendation system to recommend products to our customers when they're trying to buy a product. They click that add to cart button and they get product recommendations which are relevant to those customers. This not only helps customers get relevant products for what they're trying to buy, but also helps Office Depot increase their revenue and basket size. And we built this. This is the architecture. I'm not going to go in depth of this, but that's what we built the whole model on. And this is what I'm going to leave you guys with. Thank you.
Okay, so the next individual needs no introduction, and I'm not exaggerating about this. When I started in 1990, I was there for 11 years. The most popular IBMer in South Florida is Pete Martinez. I can't swing a dead cat anywhere in South Florida, and someone asked me, he's actually better well known than Dr. Dave. So I'll give you Pete Martinez.
I had a great opportunity to be part of this campus for 32 years, and it is marvelously exciting to see it come back to life in the way it is, so thank you for the proper partners to do that. A child is born, and something is not quite right with the kid. So immediately the physician starts saying, well, let's run this panel of tests. Let's run this sample. Let's get us some specialists. Let's run this battery of tests. 2 years later, the child has gone through incredible inconvenience, not getting better. The parents are freaking out. The bills are stacking up. Eventually, somebody will say, maybe there's a genetic disorder with this child. Let's take it to the geneticist. There are only 5,000 geneticists in this country, yet there are 4 million children born every year. 1 out of 10 could have a genetic predisposition. Do the math, and we have a challenge. So the first thing that one of the top geneticists in this country did was take the process that typically takes them about 4 days to map between a genetic sequence, what comes out of the machine from your swab, and the potential 7,000 diseases that a child could have. It takes them about 3 to 4 days manually mapping over what could be wrong and going through the whole experiment. So this very, very smart geneticist said, why don't we use artificial intelligence? Actually take my thought process and put it into a computer. So all of the mental algorithms that I'm going through are now going to be codified into it. Okay? And I wanted to learn from every case as well. So what typically took 3 to 4 days of a top geneticist, if they were only doing one case, but normally they're working on 3 or 4, so it might take weeks at a time, that was reduced from 3 to 4 days to 10 seconds. 10 seconds says now we can do massive, massive throughput for every child in this country and every child in the world. So in a very short period of time, we have introduced a process that reactively gives the parent the opportunity to say, I'd like to have my child tested very, very quickly. But if you think about it, why would we not do this for every child and proactively determine, here's the potential predisposition. Doesn't mean you're going to have a given disease, but think of all of the unnecessary tests that we could do without in the guesswork that is medicine today. So the ability to codify and understand what the architecture of the body is and our predispositions is immediate. The moment we start combining the genetic information with the clinical information, with the environmental information, with the dietary information, then we start seeing what are the trigger effects that went from a genetic predisposition to a given situation within the individual. So this is artificial intelligence. Now, the ability to codify and think very fast, look for patterns, and learn. So for every transaction that we do, the machine is actually learning, and it perfects itself with every transaction. So we now have a database of 150,000 cases in 61 countries from 1,000 different laboratories. Not one individual laboratory could consolidate all of the information, but we brought it all together, so we have the collective wisdom of 1,000 laboratories from 61 different countries. Think of the value of that for pharmaceutical companies, for health systems, for insurance groups, and for laboratories that now are looking for the faster, more effective way. So this is transformative. This is transformative in the sense that it completely accelerates and puts knowledge back in the hands of the individual. You, the parent, the child, and the health system related to it. But think of the economic disruption that it causes, because instead of being reactive and at the will of all of the tests that we could possibly go through, what if we start saying, from early onset, here's all the things that are not wrong and will not be wrong with this individual. Skip that panel of tests that cost $500,000 and all of the anguish you could possibly take an individual, a child with. We're doing it in pediatrics primarily because think of the value of the human genome at birth, and that's something of a baseline that you're going to have for life. Most of the cancer research right now is using genomics, but think of the value of that as being a very short term. 3-5 years, think of 100 years worth of valued data. So the impact here, and what we're doing is capturing massive amounts of information, and we're doing about 3,300 cases per month. So that's 3,000 families and kids that we're helping per month and improving the human condition. Thank you very much for your time.
So we're thrilled to have Jennifer Esposito from Magically. So I'll tell you that she's been pretty sick, so like the trooper, she came in. Are you okay? Okay. Fascinating academic background, her professional career is just amazing, so we're thrilled to have Jennifer.
Thank you. Now, we'll sanitize the controls. Okay. So thanks, Eric. Yeah, and I really appreciate it because I have been horribly sick and I feel horrible, but I'm going to try and stay on. So I'm from Magic Leap. I started back in January, actually, so I'm relatively new to South Florida and to Magic Leap. I've been at Intel for the prior 4 last years on the West Coast. So just curious, how many people have heard of Magic Leap? Okay, cool. That's good. I don't get that answer when I'm not in South Florida. So. That's great. So Magic Leap is based in Plantation. We were founded in 2011, and we're talking about machine learning, I'm going to talk about a different type of AI or different types of AI. Magic Leap is fundamentally a spatial computing company. So we consider that essentially a new form of computing. It's computers that actually can see what you see. And it basically combines computer vision and artificial intelligence to sort of merge the virtual content into the real world in a very seamless way, so that you really don't even understand that there's a digital and physical in between you. So when we talk about spatial computing, we talk about technology pillars, and all of these pillars are underlined by AI. You can't find a single spot here where there isn't some level of AI, whether it's machine learning or computer vision. So the first pillar that we talk about is sensory fields. And this is really your first level of interface with the world. So if you know what Magic Leap is, you know that we have these goggles, right? So that's the first thing that people think about when they think about Magic Leap. The goggles are a sensory field. It's one way that you can interact between the physical world and the human being. The second pillar is what we call live stream. And this is all of the data that you're able to collect both from the sensory field and other types of sensory fields and other sensors in the environment and around you. And it really helps take data from that, leverages AI to really create a really robust, personalized digital experience. The third area is what we call, the second, I talked about, I'm sorry about that. The third area is human-centered AI. And some of you may have seen our version of a digital human, Micah. Everybody seen that or heard of it? Okay. If not, Google it after this and watch some of the videos that are online. But Micah is our version of a human-centered AI or a digital human. And it's really taking the sensory field, the live stream, all of that sensory data, and making us able to interact with the digital content in a contextually relevant way. And so you shouldn't think of Micah as a digital assistant. It's really meant to be more collaborative. It's really to help you gain sort of that optimized experience between the digital and physical world. And you really can't do that without spatial computing. And we can talk a little bit more about Micah probably when we get to the questions. The last area is what we call the magic verse, and this might be the most hard area for us to explain. If you think about the magic verse, it is really a system of systems. It's layers upon layers of both digital and physical content that we use to describe an infinite number of application layers. And so it's a way for you, again, to bridge the physical world with the digital world, but to do it in a large scale. You could do it in a city scale, you can do it in a country scale, and it essentially allows you to create a digital twin of a physical environment and really actually think about sharing it with someone in a different location. So you no longer are bound by physical space, you're not bound by time, and that really opens up a whole lot of opportunities from the perspective of new economic opportunities. Think about the fact that if you don't need to go somewhere, you can save money, you can interact with people that you otherwise wouldn't. I run the healthcare team at Magic Leap, and this is actually probably one of the most exciting parts of what we're working on to me. It's one of the reasons I came to the company. Because I could see that, and it was a lot of like what you were saying, right? There's all of this data around people that we don't leverage in understanding their health and their wellness. And we can do that more continuously. We could take it more close to home, to the community. And so that's really why I'm super excited about this particular aspect of what we're working on. So I'm going to finish a couple minutes early and save my voice. Thank you.
So this next individual is also another person that needs no introduction. Stand by. Cindy talked about kind of having a dream PR client. Scott got paid at the end of '99 when he had a very big acquisition. Everyone knows in South Florida who Scott Adams is. So Scott, it's on yours.
Yes, and actually, that company I was talking about, we were the first tenant coming in here when IBM left. So I was driving through with a real estate agent doing golf carts through the hallways with no lights and looking at OS2 signs on the wall. So it was kind of exciting to see. And I was walking by my old office, and the third company I got involved with recently, that sold 2 years ago, they moved into my old office too. So there's a lot of home building back home here. But what I'm here to talk about in AI is in the public safety and in the security area. And as far as in our lifetimes, we get to see some innovative trends and exciting things happening. And I'm really excited about AI, just like I was really excited about the internet back in 1995. For a number of reasons. I see a lot of convergence of things like, the internet going to where it is today, the broadband and the amount of data throughput. When I do the speed test on my smartphone from the house, I'm getting the speeds that a cheap free line would be, which I used to pay $50,000 a month for. I get that on my smartphone now. It's like, that's crazy, So the other thing of that's happened is obviously the speed at which the processors are able to take data and process. Those of you who remember the old 8088 computer, that was the chip that was used in this building and stuff, with 5 1/4 floppy drives, you could read faster than what can go on the screen. And now today, it's just, so the speed of the processing power makes, AI something into reality and what it is. The other very important component which has changed everything is like, who in this room does not have a smartphone? I mean, there's maybe only a few, but almost everyone has a smartphone with them on them, and it's the amount of information in that phone and what it can do and how it changed our lives is really an important factor in what I see as the future on security, which we'll go into. And the other last piece is cloud computing. We built our own data center down the street here, around the hallway here, and spent millions of dollars. Now, everything, you never even see your computer. It's all in the cloud, and it's amazing how much the computing horsepower. You just need a new server, you push a button, you get a new server. You need 50 servers, push a button. You want multiple zones around the country, push a button. And it would take us millions of dollars a year to do that back in 20 years ago or so. The other piece that we have to talk about in security is from our society. Are we ready for what China does, knowing who we are and everywhere we go and looking at our faces, and you don't even have to even give up, announce yourself or anything, or even have an ID. I don't think our society is ready for that, no matter if that technology is available today. And then our culture in America is about freedom too. We will die for that. So we have to take that into account as we go to develop and innovate this kind of technology we have with AI. And then we also have the legal system, which is going to is evolving too. Because just like anything new, I remember when the internet first started. The legal system didn't know how to handle all these new areas of law and what happened. So, and then we have privacy expectations, and then, our current reality is we have cameras everywhere. So we know that where there are cameras on the streets and stuff, and that's just what we accept. So we have to apply common sense and transparency as we develop these new technology. So our overview is we have cloud versus edge analytics and then the machine learning that will work in conjunction with each other. And we also have the human factor. AI just brings stuff to humans to make the decisions is the way I believe that. So that way one person can be watching 1,000 cameras at the same time and then the information is brought to them. And then we have to do a real-time and integrated approach to how we're going to take all this information and respond in cases of emergencies with smart cities and use cases like active shooters in schools. When you have someone running around with a gun, you want to get information to the right people with a gun to go in the right door at the right time to stop them.
And then the last use case example is I looked at for, like my daughter's running and she pushes a button and someone's going to take her in the car. I want some, that the drone has to fly over and help her and get her before she's on the news the next day. That's good. Are we ready yet? Thank you.
Stand by. Okay, so our last speaker is Alice Rose from Modernizing Medicine, which is in BRiC, correct?
Yep.
Okay, Alice.
Great, so thank you very much. So 3 of us up here are medical software technology experts, right? And so out of 5 panelists, that's what you got. So I'm hoping there's going to be some really good questions to why you have so much medical innovation up here. Okay, so everyone here probably has an iPad or a tablet that you use to check your email, watch Netflix, read a book in bed, like me. Who would have thought, though, that 10 years ago we'd be using that same technology to capture our medical records? That's precisely what we're doing. So in the last 10 years, the use of electronic medical records has more than doubled, up to 86% now. Okay? So now that all that data that's captured in those electronic medical records and is stored securely up in the cloud, we're able to access that data and use machine learning technology in order to analyze it, to provide evidence-based knowledge that doctors can use at the point of care. Let me give you an example of how this works today. So by show of hands, who here has heard of sepsis? 50% of you, that's right. So sepsis is a really terrible condition that occurs when your body's immune system overreacts to an infection. In the United States, 1.7 million adults are diagnosed with it every year, and 270,000 people die. That is 6 times more deadly than car accidents. It is the most expensive in-hospital condition out there, and with sepsis, time matters because for every hour it goes undetected and untreated, the risk of death increases anywhere between 4 to 7%. So it's obviously something that researchers need to be looking at. And in fact, a group from UCSF has just published a study where they've leveraged EMR data to build a machine learning algorithm that uses vital signs, so 6 points of vital signs, to create a model that is able to predict what patients are going to get sepsis and when. This model is far superior than the models that are used today in healthcare. So, great, it's a study, but is any of it actually being used in healthcare? The answer is yes. So the HCA healthcare system, which runs a number of our hospitals and clinics across the United States, has been piloting their own algorithm called SPOT. SPOT uses real-time high-frequency data from their medical record in order to predict and detect what patients in their emergency rooms and ICU units are going to get sepsis. And the doctors and nurses are using this so that they can intervene more early on in patients' treatment. Sepsis is a good example, but there are many other examples in healthcare where machine learning technology is being used. In drug discovery, pharmaceutical companies are using machine learning technology to identify molecules and compounds that they'd like for further research. In diagnostic imaging, just last year, the FDA cleared the first use of a machine learning algorithm that can detect diabetic retinopathy from images of the back of the eye. And in public health, experts, epidemiologists, are using machine learning technology to improve models that already exist in order to detect when an infectious disease outbreak is going to occur, where it's going to occur, and how it's going to spread. So if we take these examples of sepsis, drug discovery, diagnostic imaging, things like that, you come to a conclusion, right, that machine learning technology has this incredible capability for us to be able to answer really, really tough problems in healthcare. Now, if I think back and I say, okay, where can we leverage this technology, right? Healthcare is clearly one of those areas. But for those of us that are working in it, it's imperative that we start leveraging the data that we now have access to in a secure, de-identified format, and this technology called machine learning or AI, to be able to help transform and impact healthcare for the better. That's what I got. Thank you.
So this is shocking that we're actually ahead of time. So I just have a question for the people in the audience. How many here are ex-IBMers? Okay, a bunch. Is it not still surreal walking around here? This is crazy. Okay, so great job. Just amazing. You feeling okay?
Yeah, I'm fine.
Okay, good.
I'm not feeling like
Yeah. Okay, so let's take questions and we'll kind of go side to side and let it run. Let it rip. Because if you don't, I have a lot of questions. I'm sure. No question? Yes.
Okay, so Scott, you had mentioned that in China, there's a lot of facial profiling, and maybe it's not going to happen too fast in the U.S. But I see in a lot of airports, CLEAR, C-L-E-A-R, where people stand in front of it with their fingerprints, and it looks at their eyes, and they get through the line faster. So how do you account for something like that?
Yeah, if you decide that you want to volunteer and put your information into a system to improve your life, then that's your decision. What I'm talking about is randomly, without your permission, walking in the street, you walking into this building and the system is taking your profile in and grabbing your information without you knowing about it and using it and saving it. That is what is scary. That's Big Brother. We don't want that. That's not good for the industry, and that's not good what I think the United States, people in the United States want.
Question? In the back?
For Pete, I just want to get your thoughts on gene sequencing by healthcare companies and insurance companies primarily, and how that could be used to set up, I guess, insurance plans in the future to either include or educate people.
The question was, how do we use gene sequencing as a model for insurance companies of the future? Think of the actuarial tables right now and how insurance is performed. It is based off what a claim was submitted for services. That's not necessarily linked to what was wrong with an individual. It's whatever was coded. The opportunity to use sequencing now as a very direct means to say, this is what an individual has and what they're predisposed to, has a transformative effect for an industry. The main reason is we can take very, very simple actuarial view of the population and say 11% of the population will be predisposed to the following. Therefore, we should have a health system that will be able to handle that level of volume in this level of region with this population set. So it actually changes the dynamics from we think we should require this much to a very predictive model of here's how you anticipate what's going to come up. So genetic sequence is only one of the elements of it, but the moment you combine genetics with biochemical, with anatomical, and with cognitive, then you get a whole perspective of the individual. And this is the power of the AI, which is now what's called multi-domain modeling, that says you take two things that are completely separate, but how somewhere the computer is able to bring them, pull them together, and now you start coming up with a very, very rational view of the world. So the sequencing is so important because it gives you the baseline, it gives you the architecture of your body, and that's where you work from. Now, your genes will actually change over a lifetime. It can change based on your environment, your diet, trauma. Deepak Chopra is big time now into by meditation, you can actually alter your genomic structure. But those are called epigenetic changes. But what you're born with is a baseline for all of the changes that's going to happen in your life.
I want to ask the panel a question. So I've always considered the term artificial intelligence as the umbrella, right? And something like machine learning is a type of AI. Does anyone disagree with that? Anyone want to talk about that? We all agree with that, right? Okay. Just making sure. Okay. Question.
So this is a question for the entire panel. I think this insurance question kind of opened up a deeper question, which is, what do you believe is currently the greatest policy concern that should be considered in AI governance?
I think, the way I see it, advancement and progress is always a double-edged sword. Advancement in AI and machine learning can lead to loss of jobs. It can lead to lack of some capabilities, but what it brings is altogether different, and the level of advancement it brings in is very different. So to your question, having what kind of governance can be brought in, and what do we lose? I think they're talking about quantum computing now, so which is the next level of compute power that can come in. And so when you log in and all your logins that you have, a very trivial case will be that you have a card saved on an app and data gets stolen, and that's a very trivial case these days. But I think there has to be governance around, and I think that's the next level of, there are a lot of universities that are coming up with courses in this area as well now, because they want people to be educated in this field. This is very critical. There's just so much data that exists today that didn't exist 10 years back. So for hackers or for people who want to steal this data, it's becoming very easy. So from a policy standpoint, I think it'll be hard to put down exactly the nuts and bolts of what that policy should be, because I don't think everybody even understands the scope of what damage can be done. We can learn from what has been done in the past, and I think there are a lot of policies that are being put in place. As you see, a lot of retailers gone through this phase of data being stolen. They have put in best practices of securing that. But when I think next level, right, your credentials or even bio data getting stolen, I think we don't have, or at least I'm not aware of, the exact things that we require to frame that policy that encompasses everything. I think we just learn and go as we come across some cases. Anybody else?
All right, I'll try to speak up. So in healthcare, there's something called HIPAA, which is privacy policy already in place that governs what you can and cannot do with what's called protected health information. So with a lot of these models that are being developed, you can develop them on what's called de-identified patient data. So it's data that you don't know who the patients are and can't tie back to them. So in healthcare, you have that protection, but what you do with that data, so the example of insurance companies, do you use that data to set up insurance policies that favor or reject based on a condition? Those are things that, from a governance perspective and a government policy issue, we really do need to be thinking about. And then the other area that for people in healthcare, the FDA, I know that we all know FDA makes sure that medical devices that we use are safe and effective for what they do, right? But one of the things that the FDA is running into that's a challenge in healthcare is that when you build products that have embedded ML, machine learning, ML is designed to improve and iterate over time. And for the FDA, there is no process in place for being able to approve that type of product that is a living thing. And so one of the things the FDA is looking at is how do they change how they certify and recertify products that have machine learning technology built into them. So that's one area.
Yeah, another example of jumping to conclusions too quickly, like recently San Francisco has banned the use of facial recognition outright. And I believe they jumped too early. There are some, they went to the Big Brother side right away, and there's a lot of really good use cases for it that they did not allow time for industry to work with the policymakers and the lawmakers to do it in a responsible way.
One of my biggest concerns is actually unintentionally we're dumbing down our brain. And if you look at if you look at the typical child right now, that they have their face buried into a smartphone looking at a YouTube video, think of how the brain evolves is through excitement. We stimulate it by stimulating the senses. And there are three functions that the brain does. First, it collects information, it communicates in and out through our senses. The second thing is it stores information and retrieves information. And the third is processes information. Think of the scenario of a YouTube video where only two of our senses, the eyes and the ears, are actually being stimulated. Second, there's nothing worthwhile storing because it's not challenging for the brain because it's there and I don't have to go back and search it. And third, there is no processing capability that's ever happening because it's being fed to you. So the biggest challenge that I see right now is we got a whole generation growing up that is completely subservient to a technology that will not force them to think.
The other thing I would add is that, yes, we absolutely have some policy challenges, but I also think there's a lot of opportunity in respect of leveraging technology and new types of technology to solve some of these concerns and these issues. You know, I think in healthcare in particular, if you think about the fact that patients in the U.S. really don't own their own data because they can't access it. Maybe they do own it, technically speaking, but they really have no fundamental way to access it across every doctor they've ever visited, every hospital they've ever been in. And so things like blockchain and other solutions that are starting to emerge are really going to, I think, enable patients in the United States to think about owning their own data and what do they want to do with it, giving people access based on what they need and what they want, and really making some choices around that.
Is there a conflict between HIPAA and GDPR in Europe? How does that work?
Well, HIPAA applies to US. GDPR is obviously Europe. And so Europe has its own privacy rules and regulations about what you can do and can and cannot do with data in general. So they don't have a specific health law. It's this broad general thing that GDPR, I'm not even sure what that stands for.
General Data Protection Regulation. So do you think that Facebook kind of screwed it up for everyone? I mean, is that the result of GDPR with Facebook and selling the data? That's he instigated it in Europe? Maybe you don't know or you don't have an opinion.
Does anyone else want to
do questions on this end? Yes.
What happens to the people? All right, so we've got these really smart machines, and as you said, Pete, our next group coming in doesn't have that same capability. And we're going to have, it seems, we're going to have some massive upheaval. It's a great opportunity, but if you look back in the 1880s, 1860s, when we started moving people off the farm with automation, and at the Great Depression, and now, what do we do for the people who are not this group? We are a technology group. We make more. We're better trained. We're better educated. We are the elite. We can't live in a separate society, in my opinion.
I think it's the advancement. It raises the tide. It helps people who are in technology and also improves the lives of people who are not. Because to your point, back in farmers using old ways of doing farming versus when technology was introduced, now their life is different. So even though they're not in technology, but their life gets affected with any kind of advancement that comes in. When there was no internet versus internet, not everybody has the the tech background, but I think as advancement comes in technology, it just raises the quality of life for everyone, if that's where your question was.
No. No, seriously, we're going to have people who don't have any of those skills. So if we automate cleaning Walmart, somebody's shop, I understand it's advancement, but there will be upheaval. And what do we do about that? And we have to take some responsibility in this transition, in my opinion. Pete, you're dying to talk.
There are a couple of very, very interesting dynamics happening. First, the basic technology is faster than we can assimilate it into society. So that's the biggest challenge. Before the Industrial Revolution, it would take 5 years, 10 years, 25 years to adopt. Now we're looking at months, days for adoption. There is going to be upheaval no matter what we do because there are going to be people out of jobs. So the government fix to all of this, oh, we'll pay you to stay home. That's not good for society, period. I think it's incumbent in our education system to start looking at what the education is for the jobs of today and tomorrow. The first one is most education right now does not have to require a 4-year degree. There are actually a lot of vocational schools. FAU University or FAU Henderson School. You got 6th graders coding artificial intelligence right now. They're easily employable, and they will make a whole lot more money than somebody necessarily graduating from an Ivy League school. So I think it's incumbent in our education system to really, really do a gut check right now because that's where it starts. The jobs of tomorrow, and I'm literally talking tomorrow, are not becoming very evident, very visible, or we're not training the people for. Yeah.
And if I can just add on to that, so for healthcare, we think of it, and someone else mentioned it earlier, maybe it's not even you, augmented intelligence. Yeah. So in healthcare, we're not thinking that this is going to be replacing doctors. It's not going to be replacing the clinical judgment that doctors are saying, you know what, based on your presentation, I think you should be taking X, Y, and Z treatment. What these systems are doing is providing that knowledge that the doctor needs when they need it, which is right next to the patient. And so that's the type of assistive technology that machine learning, AI has a really potential and power to transform.
Okay, you've been holding your hand up for 5 minutes. Go.
All right, someone posed a question to everyone. Who here thinks misinformation is a major problem in the world today?
Who thinks misinformation is a problem today? That's the question. Because it's kind of a fake news question.
Well, no, not but with generative networks, so GANs, it is becoming easier to generate fake news, fake images, fake stories, fake videos, that in the future, people won't be able to tell real from the fake. With this new technological boom coming, how will we be able to combat misinformation and not allow it to spread, to keep real news real and the fake GANs fake?
So I know that they are, with the video stuff, they are developing technologies to figure that out, that it's not a real
Right
video.
here, I can do it on my machine. I know.
Yes, but there is a lot going on behind the scenes to resolve that specific problem right now. It's seen some of the key.
Yeah, the technology that creates it also needs.
Yeah, right. Exactly. The problem that creates it, is also the solution to the problem. Any comments?
Yeah, just from a general standpoint is we just learned don't believe everything you hear. And just you don't have to go to trusted news sources and whatever else you hear, you know what, that could be fake news, so I don't waste my time on it. I'm going to focus on the areas where I feel that I want to learn about. So I think the consumer has to help drive what is the benefit for other people doing all this fake stuff.
Let's come on. Yes.
Everybody is talking about, like Elon Musk, for instance, says that artificial intelligence is dangerous. Okay, it's a dangerous move. What do you think? Do we get wiped out by artificial intelligence, yes or not?
Yeah, do we get wiped out by artificial intelligence? So, just broadly speaking, there are 3 types of AI, right? It's typically applied or narrow. Sometimes it's referred to as weak. And pretty much all of the AI technologies fall under narrow, which is really about solving a discrete problem. What's the next chess move? Answer the Jeopardy question. What's the best route from point A to B? Is this email spam? Predicting sales, weather. That's considered narrow or applied AI. There's general, and that's kind of human artificial intelligence. And that's about, understanding, reacting, adapting to your environment. Think the Terminator, right? So even the best minds think that we're 20 years away from that, so maybe to the end of the century. So I think we're a long way. Yeah, I think, I know, but I think we're safe. Let me hold. Yes.
I was thinking, what are some more of the retail applications for AI? We have a lot of things like Google gives you all kinds of suggestions based on so what are some of the other up and coming retail applications for AI?
Yeah, there are a ton of applications of AI and machine learning in Walmart and other retailers and Amazons and etc. Some of the use cases are like SKU assortment. Like how do we get the right SKUs on the shelves for the customers in the right stores? Marketing is a classic area where we leverage a lot of artificial intelligence and machine learning models to recommend products or to price products right. I even know that there are distribution center routes that the trucks take, from the ports. Even those routes are built based on the machine learning models, taking weather data into account and other things that can affect the routes. I think there's just so much data in retail that there's huge significant applications of AI. And it's all focused on making things faster and better, and things that took days to do earlier now takes minutes, and now we can move on and think about the next big thing that we want to do. And it just makes the whole process so much more advanced. Thank you for the question.
Yes,
I'm sort of this person who is just really obsessed with optimizing human performance and potential, being the absolute best that I can be as a human being on this planet while I'm here. So I'm curious to know if you have any suggestions for AI methodology that actually harnesses and can bring us more of our own human optimized potential.
That is a very profound question. The reason is, the question is, in terms of human performance, how do we optimize human performance? And that goes right to the core of how we define health so far. If you ask most physicians, what is health? They say, well, if you're not sick, therefore you're healthy. That's by exclusion. That's actually backwards. What if we redefine health as the optimal performance of mind, body, and spirit? And said, optimal performance means you're hitting your peak in each one of those things. So a fundamental understanding of what our capabilities are. One, some of the things are predisposed in us. We're built with an anatomical structure. We got a genetic structure. But understanding what the bounds are of those. I think there will come a time very, very quickly where we say, you have the prototypical body for a left midfielder in soccer. You don't have to play that position, but you have all of the gifts of everybody else that has been cognitively. You could say there are some brains that are wired differently, or mathematics versus science, or the arts versus the music and such. What is your sweet spot? That doesn't mean that you have to play it in that scenario, but you're actually understanding a whole lot more about what is inside of you and how do you accelerate. The second part is, how do you work with the areas of deficiency that you have and bring those up so you get a much more holistic performing body. But you're absolutely on point, which is we've been working on the wrong end of the equation. Okay, 98% of medical transactions are when we're sick or injured. What about the rest of the time? Okay, that's where we should be striving. Medicine should be the exception, not the rule.
One comment about the doom and gloom. A good example. Where we've seen the biggest bang for buck in AI is about the collaboration between human and machine. And this is a really simple example. Think about the Google search engine. Okay, so a lot of us we build websites, we put a ton of content out there, and then the search engine crawls through the website and indexes all of that data, memorizes it, right? And then the humans come in and they type in search, and Google serves up the content, right? Google didn't put any librarians out of business, right? In essence, they democratized all of this information and data. So traditionally, historically, these breakthroughs just, think about most companies have a marketing person and their job is in acquisition. And one of their skill set will be in SEO and paid search, right? So what Google did was create industries with tens of thousands of jobs, and we typically, historically, see that, even though it is painful along the way. Okay.
Create new kinds of jobs, right?
Yeah, we create a lot more different types of jobs. Yes, back up.
So most of the talk was about machine learning, that area of AI, and to Eric's point about different types of AI, the strong, the weak. Any of you working on more sexier projects, such as like natural language processing, or what you see in the movie where you can interact with it like a human? Like virtual assistants.
Yeah, I can talk a little bit about what we've been doing. I mentioned our human-centered AI, right? And that, again, is not meant to be an assistant, it's meant to be collaborative. So by virtue of the fact that you are wearing the magic goggles in the sensory field, the AI can be fully aware of where you are, what's changing where you are, and how you're interacting with the environment. So if there's a chair or a table.
Can you talk to the assistant?
Yeah, she can talk. Right now she can't talk, but she can hear you, and she can look at your facial expressions and engage with you from a facial expression perspective. So she will eventually talk. But if you think about the fact that what's happening there is the system is actually capturing all of this other data from the environment that you're leveraging to have that conversation, and to think about how you can really sort of engage and do things together. And it goes back to this question too about new kinds of jobs and how does that evolve. What can this human-centered AI actually help you do, and from the perspective of augmenting you and helping you do new things in a different way, versus the elimination. I think we always jump to the fact that we're going to eliminate jobs and eliminate people with AI.
Great. Just want to say, Pete, go Canes, fellow College of Engineering alum. So we talk about democratizing AI. There's a lot of products coming out on the market, like Data Robot. Oh, you can do AI and machine learning. You don't even have to be data savvy. I'm personally very concerned about that. I just wanted to hear your all's thoughts.
Well, I think it's more complicated, right? I think what we saw over the last 3 years was a lot of hype around AI, and a lot of people thought that, I used to work at Intel, so we used to focus on CPU versus GPU, and everybody thought the solution was go buy a bunch of GPU, and you can suddenly do deep learning, and your problem was solved. And that really wasn't the point. People were jumping to these absolutely extreme use cases, like in healthcare, the clinical ones, which we're not necessarily ready for, and leaving behind all of the really important simple ones, like administrative and operational and financial, that could actually still save lives and improve quality. So I think it's very complicated. People actually have a lot of the capabilities in their IT shop already to do a lot of this AI. And I think people have to step back and really understand what they're talking about doing before they sort of jump to that extreme conclusion.
So, and obviously we do use Data Robot, and your concern is valid. There's a point. I think it's a tool which enables citizen data scientists to be able to build models and get the insights from the data without really getting into the nitty-gritties of how that model is built and what is it doing in the black box. But, so there are limitations to that as well, right? So that comes with every AI tech that's out there. While Data Robot gives you the benefit of time, because what it does is you ingest the data and it runs through several models, and like 40 or 50 models, and then gives you the best prediction, right? Or best model that fits the problem that you're trying to solve. It still misses the nuances of the business knowledge or the domain that you're applying that model in. It still misses some of the things that it still needs a data scientist or somebody with the knowledge of statistics and mathematics to be able to tweak some of the features that it's not able to do on its own. So there are limitations. It's basically what it helps us save time to build some of those models, and we use that as a as a precursor result to see, okay, this is the benchmark, now can we improve on it? So that's one, and I mean, I think if you take any AI tech, has its limitations, and as someone here was mentioning that the machine learning, the whole concept is that it learns from its environment, and it builds over time. So what it is exposed to in terms of the environment and data is what it's going to learn from. So sometime back, I think Microsoft launched their chatterbot called Tay, T-A-Y. And that was a chatterbot which had a face, it was on Twitter, and it was supposed, they built the AI behind it, and then they set it free and let it interact with the world, right? So as people interacted with it, it learned over time and was able to have a good conversation. But over time, there are trolls on the internet who started using, profanity or racist slurs, etc., with the chatterbot, and that's what chatterbot learned. And within 16 hours, Microsoft had to shut down the chatterbot. So it depends. That's what machine learning is. It learns from what it's exposed to. So there's limitation to every end.
Okay, so we have 5 minutes left, and then we just have one more speaker real quick at the end here. Over here.
My question is for Jennifer. Your presentation was so impressive. It seems like the robots are coming with what Magic Leap is doing. But I think I've heard you say, and correct me if I'm wrong, a couple of times that the role is to collaborate, not to be an assistant. Can you expand on that? What's the difference between collaboration and assistance?
Well, when I say assistant, I think more in terms of someone doing something for you versus you working together to achieve something. That's my distinction.
Human, what would be collaborating versus assisting on a task that is programmed to be?
Well, I think that the human-centered AI can see your environment, right? They can lead you to help you find something, or you can work together to learn new information, expose it together. You can collaborate on, some of the demos that we've done with our human-centered AI focus around doing art together. So it's not that the AI is doing the art, it's they're helping you and working together and collaboratively put something together.
If you think about Amazon, like the inventory floor, you see all the robots that are moving stuff around, and you give it to a human, and the human takes the package. It's another example of sort of, it's a handoff, right? So that's a good example of machine, human collaboration.
We talked about my generation learning more slowly because of the do you think we get to the point where as the devices become more mobile and more interactive, that it actually accentuates the senses and helps us learn more quickly?
This is a fascinating point. Look out into the future 25 years. There's a point in time called singularity. That's when machine intelligence equals the human brain. Okay? Now, it's probably going to take a fairly large machine, very, very expensive, and it's going to take an awful lot of heat, generate an awful lot of heat. But it's trying to mimic a computer or a human brain. The fascinating thing about that point in time is that if we continue to follow Moore's law, which says computing doubles every 2 years, that means that the computational capability will continue to grow exponentially and surpass human capability. There's a flip side, which we're starting to understand now, which is, what if we actually use more of the human brain as a computer than a computer as a human brain? What if we could actually program and communicate directly into a neuron level and bypass the senses and now start using very, very sophisticated computers that are the size of my fist and only generate 200 watts of electricity, and start replicating those, and actually you start creating banks of brains that are actually acting as computers. Think of that.
2 more questions, and then we just have one more speaker. Yes.
So I have a question. I'm from the field of education, and you talked about, students and, vocation, and typically I work with populations that will go into the field of vocation and they go to technical schools. So my question is, outside of me already envisioning perhaps AI kind of taking the place of a lot of educators in the future, do you see AI assisting students who really have very low IQs that we know are only going to increase a certain percentage point, even knowing that the brain has a certain level of neuroplasticity and that it can increase in some degrees, but how do you see that really playing a role in, because we can't just wipe out people who have lower IQs, so how do we assist that population in really being able to reach this level in which they can perhaps do some of these fields in which we're geared towards in the future, but like research shows and kind of brain research shows that they're probably not going to get there on their own.
I'll attempt to try to address that one. So, human life's sacred, right? So everyone deserves to have the ability to live, work independently. So the type of technology that can assist folks that may be impaired in some way, that type of technology that's assistive in that particular instance, that's assistive in helping do chores or helping to remind folks to make sure you take your medicine or you set your alarm for the next day. That's the type of technology that can assist that audience in that group.
Okay. One more question, and then we're going to be up here, so you can come afterwards. I just want to be mindful of people's time. You right there, yes.
Yeah,
that's you.
So a quick comment is, first is, I took Google Maps over here, and it took me to the wrong parking lot.
Everyone is in a probability.
But generally, these AI machines, they're developed based upon web services, like Amazon has web services, and IBM and Microsoft, they all have their own tools. Okay, so my real question is, so if somebody develops part of the genetic solution with Amazon tools, and somebody else develops another part of the genetic solution with IBM tools, how combinable are these two processes to make one better process? Or is it going to be just Amazon tools combined with Amazon tools and Microsoft tools designed with just Microsoft tools? Or is there I appreciate some future vision on that particular.
In today's industry, there are a lot of, they're still coming up, but there are a lot of tools and applications that now can do cross-cloud computing. So many companies today have GCP, which is Google Cloud, and also Amazon, and also have Azure. So there are tools and applications that can now do cross-cloud computing pretty effectively, because that's in fact of the industry that everybody was in AWS, and there are other cloud platforms coming out which are very effective. So they have to develop applications that can do cross-cloud.
And a lot of the tools that are used in the cloud platforms are all the same too, on the containers, the microprocessing, and the machine learning tools are many times the same exact ones, just in a different environment.
That's a good question. Okay, so just to close this out, thank you for everyone for coming. This has been great. I want to introduce Danielle. She's the GM here of BRiC.
Hi, thank you guys all for attending the event. We are so privileged to have such amazing people in our community that are forward-thinking and innovative. We are privileged to live in such an amazing South Florida environment. Our weather, our schools, our live, work, play is fantastic. But we also have this very human underlying need for innovation, technology, and creating new things. IBM had created that foundation back in the late 60s, early 70s. They created this amazing campus of 1.7 million square feet where so many fantastic things came. Our motto here is "The future began here," and we're starting to see that take shape again as we welcome companies like Modernizing Medicine onto the campus. BRiC is starting to see a rebirth of innovation. We want to continue to support that, so we thank you all for coming to this event, and we continue to host things, and we continue to get the word out as we're trying to establish Boca in South Florida as more of an innovative hub. So we look forward to more support from you guys, and thank you again to all of our panelists for being here. I think this was a fantastic event. Again, they're all going to be here. If you have any questions about the campus, I'm happy to answer as well, and we look forward to seeing you guys all again in September for another fantastic event, and then the TEDx event. So thank you.
Hello. I just wanted to make the announcement. We have 2 winners for the 2 degrees, 2 tickets to TEDx. Brian Slater, if he's here. So we'll get you the tickets. And then we also, the person that guessed the number of the little mini robots in the jar for the container game app that you can download, we had Peter Simpson, who guessed 330, and it was 318. Oh. Peter? Is Peter Simpson here? We're trying to build a community of businesses and collaborative efforts, so if you're interested in learning more about TedXBocaRaton, reach out on the website or on our Facebook page. Thank you all for coming, and thank you to an amazing panel.